Okay, so we're going to talk about bonding. So the first type of bonding we're going to talk about is called ionic bonding. So before we do that, we need to talk about the electron configuration. So in the first shell of an atom, you can hold a maximum of 2 electrons. In the second, third, fourth, and fifth shell, and so on and so on and so on, you can hold a maximum of 8 electrons. So let's say, for example, if we had a situation where we had lithium, which has 3 electrons, if you just pause the video and try and draw the electron configuration of lithium, and I'll give you a bit of a clue, it's got 3 shells. So if you try and do that now. Okay, so hopefully you've done that, and you realise lithium's got 3 electrons. First shell can hold a maximum of 2, so the first shell will take those 2 electrons. That gives us 1 more electron we need to place on the second shell. Okay, so now let's say, for example, I have a atom sodium, which is represented by the letter Na, and this sodium has 11 electrons. So pause the video and see if you can have a go at drawing the electron configuration of sodium, and I'll give you a bit of a clue. It's got 1, 2, 3 shells that are required. Okay, so if you've done that and you realise first shell takes a maximum of 2, second shell takes a maximum of 8, so now we have placed 10 electrons in total on this atom, so therefore I'll have 1 final electron on the outer shell. Okay, then if I was to leave that there, and now I'm going to draw the atom fluorine, and that has an electron configuration of 9. So see if you can draw that, and this time I won't give you a clue about how many shells you need. So pause the video and have a go. Okay, so if you've done that, and we realise first shell, I'm going to draw these with dots rather than crosses this time around, has 2. Second shell has got 1, 2, 3, 4. I'm actually going to put this one over here, 4, 5, 6, 7. So what we can say then is we can say that the sodium atom has 1 electron on its outer shell, and so therefore we are going to say that this sodium atom is going to be found in group 1 on the periodic table, as the group number is dictated by how many electrons you find on the outer shell. So if you pause the video and try and tell me what group number fluorine would be in. Okay, so hopefully you've done that and you realise that fluorine would be in group 7, as it has 7 electrons on its outer shell. Now, as a good rule of thumb, atoms, although they don't have personalities, they like to seek full outer shells in order to become stable. So the best way that this sodium atom here can get a full outer shell is by 2 options. Either they can lose 1 electron, in which case they will then have a full outer shell, or they would need to gain 7 electrons. And clearly losing 1 electron is going to be easier than gaining 7. So when sodium reacts, it tends to lose 1 electron. So if it loses this electron, like so, it now has 10 electrons. Now, this is a starting number that it did originally have. Sodium had the starting number, its atomic number of 11. 11 actually dictates the number of protons as well as the number of starting electrons there are present in an atom. So there'll be 11 protons and now 10 electrons. Before sodium lost that electron, there were 11 electrons and we had this outer shell here with 1 electron on. But now that electron has been lost. To give sodium a full outer shell, I'm now down to 10 electrons and 11 protons. So therefore, what has happened here is the sodium atom has become slightly more positive than slightly negative, because electrons are negative, protons are positive. So there are more positive parts than there are negative parts by 1. So 10 to 11 is just by 1. So this is now turned into sodium 1+. which I generally tend to write as just sodium Na plus. Okay, so if we were to have a think now about fluorine in group 7, see if you can pause the video and tell me a way that we could get fluorine to have a full outer shell. And it's something to do with either gaining or losing electrons and how many. Okay, so I hope you've done that and you've realized that in order for fluorine to have a full outer shell, it would be better gaining 1 electron rather than trying to lose the 7. So it gains 1 electron, and let's say it happens to gain the electron that sodium lost. So the electron that came from sodium is now going to join to fluorine. Okay, so let's have a look here. This number 9 was representing the number of protons as well as the number of electrons before there were any changes, and protons are positive. Now we have a situation where we have how many electrons. So if you can pause the video and tell me how many electrons we now have. Okay, so we now realize we have 10 electrons, and electrons have a charge that is negative. So now we have 9 positive protons, 10 negative electrons. This is going to be more negative than it is positive, and that is going to be Y1. So I'm going to write F1 minus, or I just write F minus. Okay, so this works out quite well, because now what we've got is we've got sodium Na with a positive charge and fluorine with a negative charge, and they're going to be attracted to each other because of the opposite forces, and these are called electrostatic force. And this is therefore going to create an ionic bond between our sodium Na and our fluorine. So if you pause the video and try and explain to me how the ionic bond has formed between sodium and fluorine, and we want to be using the word lose, we want to be using the word gain, we want to be using the word electron, and we want to be using the word positive and negative. Okay, so have a go at that. Okay, so hopefully we've said that sodium loses 1 electron in order to become a positively charged ion. Fluorine gains 1 electron in order to become a negatively charged ion, and the opposite electrostatic forces cause the attraction between the 2 atoms, which is called an ionic bond. Okay, so let's then have a look at this with 2 different atoms this time. So this atom, I'm going to say I've got 1 atom in group 2. So I'm going to say I've got a group 2 atom here, group 2 atom. So if this is the outer shell of a group 2 atom, could you please pause the video and tell me how many electrons there would be on the outer shell? Okay, so we've done that, and we have realized there are 2 electrons on the outer shell of this atom. And then if I went to a group 6 atom, could you please pause the video and write down how many electrons there would be on the outer shell? Okay, so I hope you've done that. And we've realized there would be 6. 1, 2, 3, 4, 5, 6. Okay, so how is group 6 going to make itself stable? Could you pause the video and explain what is the best way for group 6 to make it stable? And making it stable would mean it needs 8 electrons on its outer shell. Okay, so I hope you've done that, and you realize we're going to need to gain 2 electrons. Okay, and then if we pause the video and have a go at trying to explain how this group 2 atom would end up being stable. So hopefully we've realized if we get rid of these 2 electrons, if we lose these 2 electrons, we're then going to be able to have a full outer shell, which is going to be found inside here, but I haven't drawn it. So these 2 electrons are going to go over to this atom over here in group 6. So therefore, that is going to change the charge of this group 2 atom. This group 2 atom, which I am going to say is magnesium, Mg, is now going to have what charge? Let's have a think. We have lost 2 negative electrons to this atom over here, So if we've lost 2 negative electrons, but we've kept the same amount of positive protons, we are now going to have a situation where we have a positive ion, and that will be by 2. So 2 positive would be the representation of this ion. Whereas our group 6 atom on this side, which say for example might be oxygen, we're going to have gained these 2 extra electrons. So pause the video and write down what the symbol for oxygen would be. So hopefully you realise that would be 2 minus. And then what is going to happen is there's going to be an ionic bond which forms between the Mg2 and the O2 minus because of these electrostatic forces. Now, it is worth noting that this bond between the 2 plus and the 2 minus is going to be a little bit stronger than our original bond, which was between sodium plus and fluorine minus, as there is now a slightly greater electrostatic force. Okay, so if you then have a look at this next one, if I was to react, let's go with group 3, if I was to have a group 3 atom reacting with a group what atom? See if you can, oh, I've already told you, so that's a bit silly, but a group 5 atom. So group 3, I'm going to have 3 electrons on my outer shell, 1, 2, 3. Group 5, I'm going to have 5 electrons on my outer shell, 1, 2, 3, 4, 5. So what's going to end up happening is I'm going to have these electrons transferring over onto this atom here to give this a full outer shell, and therefore this has lost 3 electrons, so therefore going to have a charge of 3 plus. This has gained 3 electrons, is going to have a charge of 3 minus joined together, and there's going to therefore be a stronger electrostatic force between these 2 atoms. So sometimes what we do is we represent ionic bonds by what we call dotting cross diagrams. So let's say, for example, I had lithium here, which has, I'm just drawing its outer shell. I'm going to write Al here, and it is in group 1, so therefore it is going to have 1 electron in its outer shell. And on this side, I'm going to draw fluorine, which has 7 electrons in its outer shell. 1, 2, 3, 4, 5, 6, 7. Okay, so if I was to create an ionic bond, I would end up having lithium, but it's going to have no electrons on its outer shell, which actually means it's going to have a full inner shell, because the first shell only takes 2 electrons, so that's happy. But that is therefore going to have what charge now? So if you can pause the video and explain to me what charge it will have and why. Okay, so it is going to be positive charge because it's lost 1 of its negative electrons, and that's going to be bonded to fluorine, which we can now show with its 7 electrons, plus also now that electron that's been given to it by lithium, and that is going to have a negative charge. So this is our dot and cross diagram to show our ionic bond between lithium and fluorine. Okay, so if you can now have a go at doing a dot and cross diagram to show the bond between magnesium, which I said was in group 2, and oxygen, which I said was in group 6. So if I start with this here, and this here, 1, 2, and see if you can finish that off. Okay, so hopefully we've done magnesium that has lost both of those electrons to give it a full outer shell, which can't be seen, and therefore that is going to be 2 plus, and that is going to be bonded to oxygen, which is going to have acquired those 2 electrons, and therefore have a charge of 2 minus, and that's our ionic bond.